Hi everyone, we're going to go over the first part of our concentration calculations. So we're going to be focusing on parts per million, percent by mass, percent by volume. So I'm going to go through one example of each and show you how to use the formulas, and then you're going to go ahead and practice the questions I posted for you. So concentration is a measure of the amount of a substance per unit volume. So we're usually going to be thinking about the substance as our solute, so what has been dissolved, per unit volume. And sometimes mass. So keep in mind that's going to be based on either our solvent, which is usually water, or the solution. And just remember that your solution is both the solute plus the solvent. So for the calculations we're going to be doing, we're going to focus in on the solute and then the total solution. Just two terms to be aware of. If we talk about a solution that's concentrated, that means it's relatively strong in comparison to something else. However, if something's diluted, that usually means it's relatively weak, meaning you have very little solute in your solvent or in the total solution. So just two terms to be aware of. So this very first calculation focuses in on parts per million. So usually we use this if we have something that's in a very small amount in a really big amount of solution or solvent. So in parts per million, this formula is right on your reference table and they make it very clear what's going where. So we're looking at parts per million and then we're going to look at the mass of the solute over the total mass of solution times a million. So when we read this practice problem, it says we have about 0.0047 grams of ammonia. So that's going to be our solute. Okay, that are dissolved in 20 grams of water. When they give you the water amount, you have to remember that that's just your solvent, not the total solution. So when this says to express this in parts per million, we have to keep in mind, really in this case, the denominator. So parts per million you can abbreviate as ppm. So we're going to have the mass of our solute, which is 0.0047 grams, over the mass of our solution. So with solution, we have to actually add these two together in order to get the solution. So on the bottom here, we would have 20.0 plus 0.0047 grams. And then you could actually go ahead and add those together, and then we show the times 1 million. Okay, and again, we're adding them together at the bottom because the 20 grams is only the solvent, the water amount, and we have to have the total solution, so it has to include the mass of both the solute and the solvent. So after plugging this in, we can round. Usually to the tenths places acceptable for Regents chemistry. We would have 234.9 parts per million. Okay. All right, if we do percent by mass, it's going to look super similar. Now, in the reference tables, they have percent composition by mass as part over whole times 100. I usually tell students it's helpful to then look at the parts per million to recognize that the part is going to be the solute, just like parts per million, and the whole is going to be the solution, just like in parts per million. But the difference here is instead of multiplying it by a million, we're multiplying it by 100. So what is the percent by mass of a solution containing 12.3 grams of caffeine that's dissolved in 100 grams of water? So the 12.3 grams of caffeine, that's our solute, and then the 100 grams of water is our solvent. So for percent by mass, we're going to have the mass of our solute, which is that 12.3 grams, over the total mass. In this case, I'm just going to add them together. We're going to add the 12.3, the mass of our solute, plus the 100 grams of water to get 112.3 grams. And then remember that this is only times 100. So when you actually go and plug that in, you'll get, for this solution, 11.0%. Okay. And then finally, for percent by volume, this isn't on the reference table, but again, this is exactly the same as percent by mass, except we're looking at volumes, usually milliliters or sometimes liters. Now, one thing I am going to have you change on here is that instead of doing this with water, we're going to say that it's dissolved in 85.0 milliliters of the solution. Or actually, I'm going to say kind of how you're going to see it on the practice. Glycerin contained in 85 milliliters of solution, just so you can see a comparison, because you're going to kind of be going back and forth. when you do a little bit of practice. So this says, what is the percent by volume of a solution that contains 18.2 milliliters of glycerin? That's our solute. And then I changed this to be 18.2 milliliters of glycerin contained in 85.0 milliliters of solution. So in this case, I'm saying that is the solution. So when we go and set the percent by volume up, I'm going to have my solute over, in this case, that 85 I said was the solution. So we're not going to add anything together. I'm just going to use 85.0 times 100. And when you plug that in, you can just round it to the tenths. You get 21.4%. So again, I think the trickiest thing with these is just identifying when they're giving you solvent that the solute's being dissolved in versus the solution. And again, that's just kind of remembering this little part here, that the solution equals the sum of the solute and the solvent. All right, please go ahead and try out some of these practice questions on your own and then do the little assessment for me. Thank you.